Hello, my name is Jonah Murvitz, and this is Physics 2211, Lab 4. Introduction. Purpose of this lab is to use a spring mass system to observe the energy principle. We observed the motion of a spring with mass on it and attempted to reconstruct that motion that we obtained in Tracker in GlowScript with fundamental physics principles. Key concepts, we got F net equals change in momentum over change in time. Velocity and position update formulas, RF equals RI plus V average delta T, VF equals VI plus acceleration delta T, or F net over M delta T. Key concepts continued. We got acceleration due to gravity is 9.8 meters per second squared. Spring force equals negative K spring constant times the difference in the magnitude of the stretched or compressed length of the spring minus the relaxed length of the spring times L hat, which is the direction that the force is acting. Then we got change in energy of the system equals work plus heat. Lastly, we got change in gravitational potential energy is mg delta y. Spring potential energy is 1/2 ks squared, where s equals L minus L naught as before. And then kinetic energy is 1/2 mv squared. Preview. Total energy is conserved, meaning no addition or loss of energy within the system. The energies in the real experiment don't exchange too much with one another, leading to minimal energy loss. Therefore, the experimental model and computer model don't differ by too much. This concept helps show how the energy principle to be true through the experiment. System and surroundings. The system is the mass of spring into the earth. Surroundings, there's no surroundings because we ignore air resistance and are already including earth. GlowScript model initial conditions. So from the video we found the ball mass is 0.402 and through Tracker we got the ball position is negative 0.8390 and then the initial ball velocity is 0, 0, 0 because it starts from rest. And we got gravitational acceleration, and then we have Ks, which we found from T equals 2 pi root m over K, isolating K and plugging in T as 9.49 that we found from the video. GlowScript model continued. We got L equals ball position minus spring position, L hat equals L over magnitude of L, S equals magnitude of L minus L naught. And then the second part of that is just using those 4 lines to compute the system energies using the definitions from before. And then for the timing, we got T starts at 0 and then steps 1 over 210 seconds. GlowScript model continued. We have defining the initial energies as before, calculating gravitational force and the spring force and the net force by adding just the 2 forces together. And we applied the momentum principle to update the velocity and position, of course, and then update the spring position following that. And on the right side, it's just calculating the energy changes inside of the loop. Graphs in conclusion, we got delta U spring and delta U grav are opposite signs of each other, meaning they are equal in magnitude but have opposite signs, and when one's at a min, one's at a max, the other's at a max, and similarly, the kinetic energy, when both of those are at either mins or maxes, kinetic energy is at 0. Graphs in conclusion continued. We have the position versus time graphs. Y position, the experimental model lines up pretty well, but for the X position, the experimental model doesn't line up super well with our model, and that's because we didn't really include the initial X velocity vector. Possible sources of error, human error in Tracker, air resistance not accounted for, and other energy transfers like thermal not accounted for. Discussion. The energy principle is satisfied through our model because the change in total energy is always 0 throughout the experiment. This means the energy in the system is just changing forms, not being lost. An example of this is how I said before, gravitational spring potential energy are exactly opposite to each other. So overall, system doesn't gain or lose energy, it just converts. Analysis of Tracker data, we got the X oscillation average time is 1.61 seconds. Y oscillation average time is 1.67 seconds. A difference of 0.06 seconds could be caused by air resistance or something else we didn't account for, and most likely also explains the discrepancies in the graphs. From the energy graph before, it's apparent that the spring and gravitational potential energies oppose each other. The kinetic energy oscillates as well. It's 0 when the potential energies are at maximums and minimums, and non-zero when the potential energies are not at those. The position graphs are decently consistent with the model and line up to an extent. However, they aren't exactly consistent, with the X position being less consistent than the Y, of course. Overall, our experiment does support the energy whole energy discussion, and it was successful.